All right, so we're going to keep going. Next, we've got 7-117. Okay. And let's look at what that one looks like. So for A, let's see. So we're looking at the previous problem. We found that, again, the answers can keep going forever and ever. And so how would we show all of these? So we're going to analyze this process by graphing the inequality we had from the previous problem. So A tells us to start by drawing a number line and plot as many of the points as we can. So I'm actually going to go back first, and I'm going to review how we would solve this. So remember, we have to solve doing inverse operations, right? So since this is addition, I have to solve by subtracting. I'll fill in that 0 just to make it easier. Okay, so then remember I can bring everything down, so I end up with this as my solution, right? So the number of hours spent studying for history is more than 1 3/4, or 1 hour and 45 minutes. So let's go and start plotting what it would look like on a number line. So again, it's anything bigger than 1.75. So if we plotted that, then that means, okay, this could work, right? So I can say 1.75. I could plot 1.76, 1.77, 1.78, 1.79, and it just keeps going and going and going and going and going, right? So it says, what is happening? Well, what's happening is that your number line is just going to start filling up because it can keep going and going and going because it's anything bigger than that. So for B, it said, what would it look like if you plot all of the values? So we would think about it like this. Okay, so it's 1.75, right? We talked about, sorry, anything bigger than that. So it'd be 1.76, 1.77, 1.78. And again, you're going to run out of room, right? So what we do mathematically is that it's just going to keep going. So we talked about this in the notes. If we plot this, it's going to be all of those numbers, right? So it's anything bigger. It'll keep going forever. So we represent it with an arrow. And C asks us, where would the line that is formed by the plots end, right? That is, what would be the boundary line of those solutions? And again, we just kind of talked about that the lower end of those would be this 1.75, right? And the upper end would be to extend forever. There is no ending there. So C talks about the low end would be at 1.75, and the high end would be just go on forever and ever and ever. So D asks us, is the boundary line for the point included? And if it is, it'd be a filled in dot. If not, then it has an open dot. So this is what was similar to recorded in the math notes. So I'm going to go back and do this again. So we've got this. It has to be more than this. And when we solved, right, we did all the work in the previous problem, we end up getting this. Okay, and what I need you to realize when you plot this is from our notes earlier, is that if we do not have an equal to, so this symbol right here is just greater than. So when we plot this, we've got 175, right? And it's anything bigger than that. So it's going to be all of those numbers. But because it's not greater than or equal to, it's just greater than, you're going to have your circle or your dot be open. Okay, so that means that 1.75 can't be a solution. It's anything bigger than that. And finally, we'll go with E. And I think we kind of just solved that one. I already showed you how to do that, but we'll do it anyway. E is going to look like this. We talked about when we solved it, it looks like this. And since it is not greater than or equal to, it's just greater than, you have an open.